All right, let's talk about AI. We all hear about NVIDIA's chips, right? They're the engines driving this whole AI revolution. But what about the software? What's the secret sauce that actually lets developers tap into all that power? Well, that's exactly what we're diving into today. We're going to look under the hood at NVIDIA's CUDA-X platform, the software that's literally accelerating the future of AI and science. So here's the plan. We're going to start with the why, the huge compute problem that even created the need for something like CUDA-X. Then we'll get into the what CUDA-X actually is. We'll break down its key parts, microservices versus libraries. And then, the best part, we'll see the amazing things it's doing out in the real world. Okay, first things first, the AI compute problem. To really get why CUDA-X is such a game changer, you have to understand the mountain that developers and scientists are trying to climb. So think about it. For a company to build a really powerful, unique AI, they need to train it on their own data. And we're not talking about a few spreadsheets here. We're talking about data sets that are growing by zettabytes every single year. I mean, what even is a zettabyte? It's a 1 followed by 21 zeros. It's just a mind-boggling amount of information. And right there, that's the problem. This data explosion creates this gigantic bottleneck. I mean, you could have the most valuable data on the planet, but if you can't actually process it efficiently, it's useless. So what do? How on earth do you solve a problem that big? And that question, well, that leads us directly to our topic today, NVIDIA CUDA-X. And what's really important to get is that this isn't just about throwing more horsepower at the problem. No, this is about a smarter approach. It's a specialized toolkit built from the ground up to make the whole process faster and more efficient. Okay, so what is CUDA-X exactly? First off, it's not a single piece of software. It's more like a giant, powerful toolbox. It's a whole collection of libraries, tools, and tech that are all built on top of CUDA. Now, CUDA itself is NVIDIA's foundational language for talking to its GPUs. So CUDA-X is like a set of specialized power tools that lets developers build incredibly high-performance apps for data processing, for AI, and for what's called HPC, or high-performance computing. I love this analogy. It really clicks. If you think of the base CUDA platform as the raw engine, the source of all that incredible horsepower, then CUDA-X is the precision toolkit. It's the set of specialized wrenches, diagnostics, and high-tech parts that lets a developer take that engine and build a Formula One race car. Okay, so we have this amazing toolkit. How do people actually use it? Well, CUDA-X offers its power in two main flavors, giving developers a choice in how they want to build, through microservices or through libraries. So let's break that down. On one hand, you've got CUDA-X Microservices. The easiest way to think of these is like ready-made components you can just plug in. They are packaged as cloud APIs, so they're super easy to integrate and customize. Then, on the other hand, you have the CUDA-X libraries, and this is the deep dive option. We're talking over 400 specialized libraries that are like the raw building blocks for developers who want to get their hands dirty and really build, optimize, and scale their apps from the ground up. And these aren't just simple little tools. These microservices are total powerhouses. I mean, look at this. Instead of spending months or years building a custom speech and translation AI, a dev can just plug in NVIDIA Riva. Want to run super high-res climate simulations? There's a microservice for that. Earth too. They're basically expert-level solutions, boxed up and ready to go for some of the hardest problems out there. All right, so that's the microservices side. Now let's get our hands dirty and look at those 400-plus libraries. And this isn't just a junk drawer of code, okay? It's all very intentionally organized into three main pillars that really cover the whole journey of modern computing and AI development. And here they are. It really tells a story, doesn't it? Step one, you've got data processing. You have to tame all that raw data, those zettabytes we talked about. Then, step two, you build your AI on top of that processed data. And finally, step three, use that AI for high-performance computing, tackling the really huge, complex scientific simulations. It's the whole workflow. And this is so important. The whole point of the CUDA-X libraries is to accelerate every single step of that journey. It's not just about making the AI training part go faster. No, it's about speeding up everything, from the moment you touch the raw data to the second you deploy your final application. Okay, theory is great, but this is where the rubber meets the road. Let's talk about the actual mind-blowing breakthroughs that are happening right now because of this technology. This is the fun part. Check this out. In drug discovery, figuring out the 3D shape of a protein is everything. It's how you design new medicines.
and it used to take months of intense lab work for a single protein. Months. Now, using the AlphaFold model, accelerated by a CUDA-X library, it takes minutes. I mean, just think about that. What used to be a PhD project is now a coffee break. That's insane. And it's not just protein folding. Take genomics. This chart says it all. The blue bar is your traditional method. And the green bar? That's what happens when you use CUDA-X libraries like Rapids. We're talking a 925 times speed up. In the real world, that means scientists can analyze millions of cells in a few seconds. It's completely changing the pace of biological research.
Okay, if you thought the last one was crazy, get ready for this. A team of researchers needed to build a huge database for developing new batteries. Using the old ways, it was projected to take them, wait for it, 20 years. 2 decades. With CUDA-X, they did it in 4 days, from 20 years to a long weekend. That's just, I don't even have words for that kind of acceleration. So this table just kind of puts it all together neatly. You can see the field, you can see the incredible breakthrough, and you can see the exact tools from the CUDA-X toolkit that made it happen. It's a straight line from the technology to the scientific discovery.
Let's stick with the planet for a second. This is huge. Using these tools, scientists can now predict a hurricane's path 39 hours before it even technically exists. Think about the head start that gives people for evacuations and preparation. It's literally a life-saving technology. And on top of that, it shrinks the massive weather data files down, making it way easier for scientists everywhere to work with.
So who is using all this stuff? Well, that's maybe the most important part. This isn't some secret tool locked away in a lab somewhere. We're talking about a thriving ecosystem of over 1 million developers, 1 million people all over the world building on this platform. And they can use it pretty much anywhere they want, whether you're a developer coding on your workstation at home, a researcher using a giant supercomputer, or a company deploying on AWS, Azure, or Google Cloud. It's there. It even runs on tiny little IoT devices. It is truly everywhere. And really, that's what it all comes down to. This is the whole point. It's about giving developers the fastest, most efficient path to take all that computing power and aim it squarely at the world's toughest problems. So, when you put a toolkit this powerful into the hands of 1 million smart, creative people, the question really becomes, what's next? What problem that seems impossible today will be solved tomorrow? What breakthrough is just around the corner, waiting to be accelerated?